Good. So thank you to Barry and thank you for everybody. It's just my second virtual meeting. I'm still a bit nervous about the technology, you know. Anyway, let's try to make it nice. Today we'll talk about something about that I'm working on in a couple of years. And it's kind of a topic that is very interesting to me, something that I'm quite passionate about, and it's about going beyond acceptance test. So before starting, I'm Roberto, by the way. I will send you some, and the last slides that have my reference, but let's go to the meaty part of the talk. Before starting to look at the topic today, there is a bit of a premise that I want to do, which is if we are serious about quality, we need to consider that for little external quality, we have a lot of internal quality, which is very important for our job. And to have all this good practice on testing and testability is really important, even if the user won't see them, because those are those that are allowed to have a better external quality. And we often hear about this idea of the total cost of quality, something like, okay, let's try to be pragmatic about quality. We don't want a perfect quality. We want something in the middle. But this idea of cost of quality, I think, is a kind of a very misleading idea. Because actually, a better idea is to go to the price of not meeting quality. How much does it cost not meeting quality? Once we, this is an older book, but still very good. And the point of the book is that the quality is free, meaning that once you arrive at a good quality, keeping a good quality in your code, in your process, is not much effort. It's not more effort than keeping an average quality. The point is going there to have a good quality. But that's why we are talking today, because today we are talking on a tool that will allow us to improve our quality, and for sure it will work very well for us. But I needed to do this premise because it's not the most easy to use tool, and it requires actually using our brain and having some thinking about. It's not just some framework that does everything for you, but I hope that can be useful. Oh yeah, sorry, there's a, I think I need to. So there is this idea of hexagonal architecture that works in all the context. And if you are working using hexagonal architecture, that means that you keep all your domain in the middle, and you separate completely what is your business domain from your technological adapter. It's also called a pods and adapter architecture. And it's also this something is that we do if we want a quality. If we wanted to deliver something as fast as possible, we probably don't care much about hexagonal architecture. But humor me, let's pretend that we care about quality. And so the next step is, okay, yeah, this is quite bad, but yeah. We have this hexagonal architecture of microservice. So each microservice will have its own hexagon, and the external layer of the microservice talk to each other. And this is more or less the situation in the team where I'm working now. And the kind of challenging part is that we wanted to test that everything works. But we also want to test that the domain actually match each other. And because in a sense, if we want to do kind of going back to monolith, we can imagine to put all the domain together and get rid of all the adapters, and the domain should be able to talk to each other again. I mean, to keep talking to each other even without the adapters. But how can we test this? And I want to talk a bit about our journey, which is not totally my journey, because I joined this team when there was already in midway. But my previous experience was really similar, so it really rings a bell with me. So the original idea is that something that you may have heard, that there is this testing pyramid, where you have a lot of unit tests, a bit less component test, integration test, system tests, and very little manual test. Now, there is nothing wrong with this test pyramid, and it's kind of true, but I think it's kind of misleading, because what we really want is to start with the acceptance test. I mean, there is this great book that talk about acceptance test first, basically. And it's funny that, yeah, some people is saying last year, yeah, there should be a book about this. And yeah, the author of the book was responding, yeah, probably. He wrote the book more than 10 years ago. By the way, Nat Price was the architect in the team that I'm working now. So this, many of this idea came from him. And then we also improve on that. Well, improve, we implemented, let's say. So the idea is that it's true that we have a test pyramid, but it's not true that we start a pyramid with unit test. We wanted to start from acceptance test, because the acceptance test is where we set basically what are acceptance criteria for our application. And a typical tool to use acceptance test is, for example, Cucumber, which is kind of nice, but it has some problems. And one of the problems is that, yeah, it seems nice when you type, but then this is an external language, which is not exactly, it doesn't compile directly in your code. And also the Cucumber test tends to finish with a lot of UI detail. I mean, this is really a lot of detail that I don't really want to write on my test. I mean, I click OK or press this button. I want to write the test in more higher level when I can explain what the user should do. And there is another tool which is called Serenity, which is something called a screenplay pattern, which is nice because it allows us to describe a test in terms of scenario, but with actual code, not with an external DSL. And it's also quite nice. And the team started using this, Serenity, but they found some problems, which a bit of became quite complicated to read, even if it's kind of nice, but then when the tests are complicated, it became quite complicated to understand what's going on. And also there are still a lot of UI detail. So this is, well, the original Nat Price idea. That is, okay, let's write something that allows us to write our test only once and test both on the acceptance side, so on the end-to-end side, but also using the model alone. So the idea is that we write our test only once, and then our test will run twice. once only running, touching only the domain, and the second time running on the HTTP layer. And we can also add, if we want, a third time that, for example, use the UI using JavaScript or other layer that we may need. But we keep separating the implementation, the representation of the system from the language of the test. And this is basically this idea of a domain-driven test, because it's really driven by the domain. We wanted to write a test only using our domain language. If something is not expressible in the domain language, we don't care to test with this tool. So the idea is that, okay, let's use the domain, not the UI, to describe the scenario. Let's run multiple times to verify different abstraction, different representation of the domain. And also, we wanted to express expectation at higher level. We don't want to see in our test something like assert that X equal some technical details of the code. We want those details to be hidden from the main test. And this is, we have some experience. We try to do that, but then even if something like, for example, something like this works nice for Hello World, for real example, with our code base, they became so complicated that was really harder to follow what the test was testing. So now we decide, okay, let's hide all the expectation at all the assertions inside our test. And doing this domain-driven test gave us this benefit that we can test end-to-end. It also works as a document at higher level because we are testing the domain. So we are actually documenting how the user will assess our system. And then we check two things, that there are no business logic in the infrastructure level and no infrastructure details in the business logic. And especially the number 3 is quite important because it's quite easy to forget and put something that is logically some business logic, but hidden in some HTTP layer. But in this case, the test will make impossible to run the test without the HTTP layer. So we know that there is something wrong. And bear a little more with me, and then we'll see some concrete example. But this is the main process. So first, now we write the version of HTTP of our domain-driven test. Then we make it kind of work, so we know that the plumbing, the HTTP router and stuff is working. Then at this point we got kind of stuck, so we needed to define the model. So we work inside the hexagon. At this point we can write also the memory DDT. And once we finish the memory DDT and we finish the model, the HTTP DDT should work. If it's not working, that means there is still some gaps to close, but it's very close to, very easy to work. And this works very well because writing the HTTP layer first forces us to make a model that is easy to plug inside the HTTP layer. If we start from the model, when we do the HTTP layer, I mean, we tried and we learn this lesson. Usually, if you start from scratch from the model, then it becomes very hard to attach to our HTTP layer because of the REST API and how we wanted to design this. But basically, after more than 2 years working on this kind of stuff, we have a lot of our code base, basically. I decided to do a bit of a cleanup and took some opinionated choices and put everything on GitHub. I should add actually acknowledgement section of this because I really I in depth of many people, and also a lot of ideas came not from me, but I mostly work only on the implementation. But I'm quite happy with the result, and now we are switching our code base, internal code base, to use this also internally. So it's already in production in a sense. But okay, without further ado, this is what it will looks like. We are basically a Kotlin shop, so this is Kotlin, but it also works on Java. There is a couple of examples, one example for the moment. Then it will be. I'm pretty keen to make this work also in Java. And we kind of keep the analogy of the scenario test. So we have actors, and we have a scenario, and at the beginning there is a setting, which are basically the condition that we put in the system that we wanted to test. So here we are testing Little Red Riding Hood. So there must be a grandma living in the forest as a setup. And at rise, when the test starts, these are the steps. And the steps are defined as actors, basically, action that the actor can do. One thing to keep present is that the actor always interact with the scenario. They shouldn't interact each other. That would not have no sense for us. And also the actor always have some assertion. So either they change the state of the system, or they can verify something, like at the end we put some value because we wanted to check that the basket is what the same that at the beginning. But there is no, basically we are not asking data in the system at this level. We also tried that, but it didn't work very well. This keeps the test very easy to read. So, assuming that you're still interested, this is happened when you run from IntelliJ, for example, but it's the same also from Gradle. Basically, each step became a new test, a small test, and here you see that it's running in memory. And this is the wolf win scenario and the smart girl scenario that doesn't tell the wolf where the grandma is. And in this case, there is only memory. If there are more than one, you will run the same test also using HTTP or JavaScript. And also, this is another point that we had exchanged with Kent Beck. Discovered Kent Beck's challenge is to discover the quantity of your design revealed by a test. I liked the part of the test which are really about your test and not just extraneous setup and test mechanism. And you can see that here is basically all the steps. At this level, all the steps are just about the test. All the mechanism is one level behind, one level under. So let's see the components. I hope someone is still working, is not sleeping. But we will also do a bit of live coding later. So I hope that can help. So we have first this idea of a domain under test, which is the class that we use for the representation of our domain. And it's very important because this class basically is representing the interface between our domain and the test. So here we're expecting to have methods that can either ask the domain something, the system, or change the state of the system. And then there is the protocol, which is at which representation we wanted to run the test, in memory, HTML, etc. So this is a bit of code, just it will look like. So this is the interface. And the interface of, for example, here we have a pet shop domain. It allows us to populate it. Sorry, yeah, it's a bit. It allows us to populate the shop to buy a pet. In this case, try it means that this is a command, so it can fail. And then this is a query, so something that can return a result. We can ask a pet price, or we can ask the list of pets. And these are all our abstractions. So we have in-memory abstraction and HTTP abstraction. And HTTP, in this case, will run on localhost. Another advantage that we have is that according to environment variable, we run the same test both on localhost when we are working, but also on test environment, on staging environment when we deploy on the cloud. We cannot really run on production if there are something that changes the system, but it's something that is worth also thinking about. But so we have this interface, wrapper, and we have the two implementation. In one implementation is the HTTP one. We are using a REST client, JET in this case, and we created a request for each component. And if needed, we can also start the server. For example, if we detect that we are running on localhost, we can start the server ourselves. If we are running in external environment, we are supposed the tests are already running there. And then there is the in-memory domain, which uses this hub. The hub is the concept of hexagonal architecture, is whatever is in center of our hexagon. And this will be basically our pure domain, the protocol. And then we can just, I cut the rest of the code, but we can look at it. Okay, so next elements. There is an actor, and the actor is something that represents the idea of a real person interacting with the system. Because even if we are writing a backend to backend system, there are the action at the end always get triggered by a human or by some kind of cron or some timing. But we don't really care about the timing because, I mean, we suppose the timing it's automatically triggered. So we really wanted to test the interaction of the actor with the system. And then each actor can create a set of tasks that works as a step inside the test. The actors are also a nice way to put all the low-level assertion and test mechanism. So if I wanted to see exactly what this step comported, we need to open this step and see exactly the assertion that I'm doing. So this is what I'm saying. So here we have the function, and then the dollars will get replaced with the variable when we write the test. We run the test name. This is the command that basically we send to the domain. The domain here is implicit. And then this is the assertion. So we expect that price is equal to expected price, which came from our side. So we use the pet name to do the command and then the expected price. Sorry, to do the query and then the expected price to verify the result. And this is a command. So we pass the pet name and then we translate this in a command. And these are so we saw the domain, we saw the actors that operate on the domain. And there's all work inside the scenario, which is basically a single test. And a set of scenarios are wrapped inside the feature, which is roughly what is a test class. So I think this is quite simple. So every time we create a new class, we needed to specify with which abstraction we care about. We create our actors, and then we just create the test. And in the test, you put some fixture, you set up the scenario, and then you play with the actors. In this case, for the web pet shop, there is only one actor that check the price of lamb, of the hamster, and then decide to buy a lamb. Okay, now there are some questions that when people look at this stuff for the first time, these are the typical questions that we all did at the beginning. The first question is quite simple. Why actors at all? We can imagine to write this test directly manipulating the domain. But the problem is, as I said, first that we're doing that, we will force to have the assertion here. That was not a great idea at the end for us. And the second point is that having the interrogating directly the domain kind of hide the idea that is always a human that is interacting the system, or something that is an actor. It can be also something automatic, but there must be an input from the outside. It's not just that we are tippy-tapping the domain. There is actually an interaction from someone. So this helps us also to force the test in a way that is more realistic to the actual use scenario. Another thing that we change is that at the beginning, we have a different, okay, this is not very clear, but this idea that we are using the same actor for all the protocol. So for each protocol, I want to show you, we have a different domain, but the actor is the same. We don't have an actor HTTP, an actor in memory. We have the same actor. And that at the beginning, we have two actors. Actor was just an interface. But the problem was that at some point, people started cheating. It was very easy to cheat. And in the HTML stuff, you don't really check. You just go on. But now in this way, since the actor is doing exactly the same thing on both domain, we are really forced to write the domain in a way that is able to offer the same API to both protocols. Yes, another thing that I didn't show yet is that we have a work in progress flag. So when we start the test, we put a work in flow. I will show you soon. A work in progress, because the test we as I said, we start writing the test first, so it's not working, and it won't work for a long time. It's not like a unit test that supposed to be working after a few minutes. So we mark a test as a work in progress, and we stay as a work in progress for 1 day, 1 week, 1 month, depending on the test. But we always put a due date. So you are forced to decide when you think the test will work. After the due date, the test will fail, basically. Another question was why we are using, let me go back a second. Yeah, basically each step became a test. And this was also something that we added recently. And this is kind of nice because it makes it much easier to see where something is broken, exactly which step was broken, rather than having a big test that say broken at line 74. This kind of make it much easier to debug very quickly. And the other question related, was why not using a given when then format. This is quite a common format. And it's also a format that we use for unit test. But for this kind of test, we have a more kind of narrative, a longer narrative. So it doesn't really, I mean, in this case, it's not really given. I mean, given, then, I mean, there are several when, then. So we prefer to adopt this stage metaphor rather than just giving when, then. Okay, the other question is why bothering about the setting block at all? Which is also something that, I mean, you can skip the setting blocks, but usually we found kind of easier to set up what is the system at the beginning must be. But we don't find very useful to have a kind of a symmetrical check at the end of the state of the system, because we just want the system to be in a given state to be able to run our scenario. And yeah, why a list of steps? This is another question that when people start using this stuff, is that this is quite strict. So we cannot do anything else that just to describe a list of steps. And also this is a kind of a constraint that helps us to be focused. But enough talking. And I wanted to show you how this is IntelliJ, our code. So if I run the test, this is just yeah, little riding hood test to have an idea of a scenario. I mean, a bit of narratives. And you can see how, I mean, we have a riding hood that goes in the forest, in memory, and all the stuff that happened. And also the test is basically substitute the dollars with the parameters, and then you put the name of the actor at the beginning. So it reads quite nicely. And another test that another thing that you can do is using a browser. So if we run this test, we'll use actually Google, I mean google.com. Yeah, you can see it using the browser, looking for something and then passing the result. And the result will probably say something is failing. Yeah, because it's a search in Google, so sometimes the result is searching my name on a pesticide. And you can see here exactly the test that the step that fail, and then expect that pest aside to find, okay, it found my name only one time, not 2 times. So I can go here and say, okay, aside. This test is very flaky because it's checking on Google, but just to show, this is the expectation. And then we can just rerun, and hopefully it should work. Of course, in this case, being a completely test driven by Google, there is no domain part because we don't really have it's failing again. Now expecting 2, so apparently Google give a different result every time. But okay, I just wanted to show this. But the test that I wanted to show you mostly is the pet shop test. All this code is in GitHub, by the way, if it was not clear. Which is, this is a kind of a almost realistic application. Well, realistic not is a big word, but this application actually has 2 tests, 2 abstraction in memory and HTTP. And the HTTP is actually starting the test, starting the web server, I mean, and using a request to interrogate our web server, using JSON to pass and to send a response to the server. And you can see here that we are creating a server and starting the server on a given port. And this is our server, which is a very simple REST API that can get a list of pets, get the details on a single pet, do a post to create a new pet, and buy a pet to put to basically remove the pet from the shop. And this is HTTP4K, which is a Kotlin web server, but it can work with any web server. So what we have here is that we have the two abstraction. And this is how we can write a test. And just for the, since this is supposed to be a live coding session, I write some code live. Let's see if it works. One little things. This DDT is just a type alias for test factory, because these are not just a normal test, but are the dynamic test of JUnit 5. So they need to be marked by test factory. So if I write the test factory, is perfectly fine. But yeah, I mean, having writing as a DDT is nicer, and also will make us much faster to find it. So let's write a new one. So I can write a function. For example, let's say that we wanted to have the shop assistance. So shop assistant check the pets. And I needed to basically to create a test with the DDT scenario. And here I can actually write the test. So for example, I can, because we are, I mean, copy paste is the great best thing that we can do. I mean, we can copy from the previous test. We can put some other animals just because we can. And we want a bunny that cost 70, whatever. We put the shop, okay, so not incredibly smart, but this is the bunny, yeah. And we put the shop, and then we can say, okay, let's write the shop assistant. So let's call, I don't know, Adam, the shop assistant. So we need Adam. So we just need Adam in the directory. Okay, this is a bit of Kotlin DSL-ish thing. Just to make a kind of similar. So you get the name of the actor from the name of the variable using this Kotlin delegation. So we needed to create a shop assistant. So we use our usual copy paste. So we go to something similar to the other. So we needed to, yeah, to override the name. And we needed to have the same type. So we need, when we define an actor, we also needed to specify the domain where this actor will work. domain meaning the interface, not the specific protocol, but we needed to specify the interface. So we have the software systems now. So Adam here is able to do something. And we can, for example, we can say something like check that an animal, a pet is in the shop. Let's say that like this. And this became a method. And then I needed to pass, for example, the parrot. And then we can do the same thing with the bunny. Okay, now I needed to implement the stuff. So this will be a pet. And this this will be a step. Yes. So. Here we define basically step, and in the step we put the pet. I don't know. This is just to have a nice name on the test. Basically, this pet name will go replace it here. Why is not saying that pet? Sorry. Sorry, IntelliJ put this in the wrong class. Yeah, this should go in the shop assistant. Sorry, I was a bit confused, but yeah, here we are. And here is this our step. And yeah, we needed to check from our domain. So here we have the domain. So we can check what are our possibility for the domain. And also because, yeah, we have this query, so we can check the how it's called. We can, for example, get the pet list. And so basically here we needed to send a block of, well, basically what do we do with the answer? And the answer here is the list of pets. So we need to expect that our pet name, yes. Actually, we expect that the list of pets contains this should be a list of string. Sorry. So we expect that the pet is not null because pet can be empty, which means that pets can be empty, which means that there is some error basically. So first we check that it's not null, and then we check that contains the pet that we are looking for, which is pet.name. That's it. And then we just need to ask it. This will actually run the command inside our domain. So if we go back to the test and we run the test, where we yeah, this is we are doing two things. So we need a comma. Yes. It's clearly not running. So you can see that is actually setting up the step, and we can see that the shop assistant is working. And yeah, okay, there is a problem because it's trying to run the test to start the server the second time. It shouldn't do. Okay, my bad. But it's a bit of yeah. I need to do something. Yeah. When you start the server here, it start always. Instead, it should start only if it's not listening. And for example, we can. So this is debugging on live coding, which is but we can do something like that and then say. It's a hack, but it should work. No, it's not working. And then it's probably okay, it's probably for some reason that I'm too tired now to find the way. I will fix this stuff on later. But I think this is a bit of a technical detail. I hope you get the idea. And okay, this is the GitHub repository. This is my Twitter account. This is the blog. I'm trying to write about this. I hope you enjoy it. And I don't know exactly how it works for the question, but yeah, let me know all your questions. And at the end, it doesn't really matter much which tool do you use, but I really encourage you to start writing domain-driven tests. It really helps a lot. And I also hope my library can help someone else. But the important part is definitely the reasoning and the way to testing.
I think there are some questions in the chat.
Oh, there's sorry. I cannot.
I can read it for you if you want. So Stefan is asking, why are you using a real HTTP server for this instead of an interface?
Yes, I can say something myself too, but
yes, probably. I don't see how to use the chat, but yes, please.
Chat is on the bottom of your Zoom.
Maybe if you go out of the full screen and or maybe you can stop sharing the screen, then
yes, you need to stop sharing before that works. Yeah.
Yeah. Did I stop the sharing?
No.
No. Stop share. Yeah. Sorry. I'm clicking here, but it's not stopping.
Now it stopped.
Okay. It still doesn't show, but okay. Sorry, what was the question? I still don't.
The question was, why are you using an actual HTTP server instead of just something that behaves like an HTTP server but is just in memory?
Because I mean, it's definitely up to you. It's something that we do actually in our production, and in our experience, the stuff that behave like an HTTP server don't really behave like 100% like an HTTP server. So we prefer to use a real HTTP server. And also, I mean, it took just a few milliseconds to start. But it's definitely...
Well, but still a lot slower than running just in memory. Like 100 times slower.
Yeah, I mean, it's, yeah, let's say that is 100 milliseconds, that is still probably 1,000 times slower than running memory, but we don't have a huge number of DDT, and we have like, I don't know, probably 100 DDT. So it took like 1 minute and we only ran them before doing a commit. Well, maybe a little more than 1 minute. But yeah, it's only...
I'm used to running 100,000 tests before a commit, so then that's a bit more of a problem there, or I lead to parallelize a lot more.
Yeah, no, that's true. I mean, it's completely up to you. I mean, this worked well for us, but you can also, for us, the most important part is able to run those tests on the test environment and the staging environment where we don't start the server ourselves.
Yeah.
Yeah.
No, that you want an implementation using a HTTP server, that's, yes, I totally get that. Yeah.
Yeah, but I mean, this is a kind of a, yes, it's a good point. I mean, it's an implementation detail. It could be using the HTTP server in memory without starting a real server, which actually is quite easy also with HTTP4K.
Yeah.
Yeah. It's unrelated with the library. I mean, you can do whatever you want, but yes.
Yeah.
Makes sense. Sorry, there was other questions?
Yeah.
I don't see any more, but if somebody would like to ask something, just use the microphone and ask.
Yeah.
Yeah, you call it a wrapper. Why is it a wrapper? The interface for the domain-driven tests?
Yes. Sorry, I didn't get why using wrapper.
Why do you call it a wrapper?
Well, it kind of makes sense to have this scenario thing. For us, it kind of, yeah, made sense to have the scenario metaphor in our, to represent our test.
Yeah, for me, wrapper has a specific meaning in terms of being a proxy for something, and that is not what this is. So I wonder about the naming.
Sorry, what is a proxy? Why actor is a proxy? What?
Well, no, the domain.
Yes.
You call that a wrapper.
Yeah, well, sorry. Okay, this is just the class name. It's not even in the framework. This is just the example name.
Yeah.
It's a kind of a proxy, but it's a proxy of the real domain. So it's something that wraps around the domain, or if you want to, you can call it the representation of the domain.
But you then have an implementation of the wrapper. That sounds weird.
Oh, well, I mean, the naming, I suppose we can discuss along. It's really up to you. I mean, it's not in the framework, this how you want to call this stuff.
Mm-hmm.
But yeah, the wrapper is, so you have the domain, which is your real domain, and then you have this probably representation, I don't know, representation for test or something like that.
Oh, but your scenario only covers part of a domain. So
well, scenario cover part of the domain, but the domain cluster should cover the whole domain, or at least a bounded context if you want it to be.
Yes, okay, yeah, bounded, yeah.
Yeah, this will be kind of bounded context representation, which make a bit longer. But
okay, yeah. And your actors are really representations of the people involved, not actors like in the actor model.
Yeah, no, yeah, doesn't. It's just the scenario representation idea, nothing to do with actor models.
Okay, yeah.
But I have a question about reusing actors between different scenarios. So how it works actually? Is this framework designed to reuse these actors between different scenarios, or?
No, they are just recreated every time. The actor, at least as we use actors, is completely stateless. So it's just a nice wrapper to put the assertions and the user interaction.
What happens if you have two different scenarios and maybe the name of the method to create would be very similar, but actually there will be slight difference inside?
I mean, the point is that if we are using the same actor in different scenarios, mm-hmm. I mean, it can be because, for example, you have a scenario where a user buy a pet in one case, and the other scenario you are testing something like the discount, and you have the same test. I mean, the same step when a user buys something, mm-hmm. but the same step must be exactly the same step in both scenarios.
Yeah. Okay.
I mean, if we don't want a step to have a name that does two different things into different scenarios.
Yeah, it makes sense. Yeah, thanks for the presentation. It was really eye-opening.
And yeah, it's okay. For me, it's very educative and didactic doing this presentation because, of course, of this kind of stuff, so far we just did it in our team. So many things seems natural for us because we are doing for more than 2 years. Opening to other people, you listen new ideas, and yes, naming is the first thing that everybody, and so yes, a lot of ideas.